up first is number 5. Can somebody read it for me, please? So this is one where you have to list out all that stuff, right? So the first part that they ask you to identify is whether this is a polynomial function. So to be a polynomial function, your powers have to be positive, they have to be non-variables, and they have to be rational. So what are the only powers we have here? 4. Is 4 positive? Is it not a variable? No, it is not a variable. And is it a fraction? Is it rational? Yeah, it can be written as a fraction, right? So it qualifies. So is this a polynomial function? Yes. So you put yes, that's the first part, right? And then it says, if it is, name the degree, the leading coefficient, type, and then write it in standard form, right? All right, so type, standard form. Okay, so for standard form, all that really means is make sure that the biggest power is in the lead. So, how would you write that in standard form? Or is it in standard form? Yeah, it is. There's only one term with an exponent, and is that term in the lead? Is it all the way to the left? Yeah, so standard form is just going to be exactly what we see. So what's the degree? What's the biggest power we have? Okay, so this is a degree of 4. Is that going to make this an odd or an even? An even. So is this an S type or a W type? A W, right? Evens are W's, odds are S's. Just based off the degree. If the degree is an odd number, then it's an odd function. If the degree is an even number, then it's an even function. So the type is a W type. And what's the lead coefficient here? Pi. And you're done. Okay? Any major questions on this section? Yes or no? The lead coefficient is the coefficient on the term with the biggest power. So if the degree is 4 and this is my biggest power, right? It's the coefficient on that piece. So we normally call it the lead coefficient because when we write out our equation in standard form, we always put the biggest power first. So the lead coefficient is like the A value. If it's an odd degree, it's an S type. If it's an even degree, it's a W type. All right, any questions on 5? If the degree is an odd or an even number. So the degree is the biggest power, right? So what's the biggest power given to us here? 4. So that's my degree, right? Is 4 an odd number or an even number? It's even. So that means that this is an even function. Even functions are W types. Everybody good? Okay. So it's just taking the snakes and laying them flat, right? All right. So that's 5. 8's from the same section. So let's go through this one really quick. What's the equation for 8, please?
Equals 8x.
Cubed? All right.
Minus 4x squared plus 2 over x.
2 over x?
Yeah.
Okay. All right. So, first things first, we have to identify if this is, in fact, a polynomial function. So, the first thing is, do we have any negative powers up here? Kinda? Well, the negative 4 is the coefficient, right? So what are my powers up here? The power on x is 1, but when we write things out, how do I magically get an x in the denominator? It's a negative power, right? So if I wanted to write this without the division, right, as in when I write these out, I want my x's all in the numerator position, okay? So to do that, what I have to do is change the location of the base of x, which means that I have to add a negative power. So the power on x is actually a negative 1. That's how it wound up in the denominator. So is this a polynomial? No, and you're done. No, there's nothing to do. Stick a fork in it, move on. Not at all. So that one was kind of tricky. Okay, so again, part of a polynomial, no variables in the denominator. Because that actually means there's a negative exponent, and we can't have that. Okay? So just so you all know, if the x is in the denominator, that's called a rational expression, and that's what we're going to be doing at the end of this semester, is working with them. So I want you to understand that, like, there's a lot of functions out there that are not polynomials, but we can still work with them and manipulate them. Okay? It's just that pretty much 80 to 90% of what you've done up to this point is all working with polynomials. So this is where we start the advanced math, the advanced algebra. Chapter 5 is the end of polynomials, and then we start splitting off into different forms past that. Okay? So up next is number 13. Looking number 13. What you got?
Equals x plus 1/2 x to the 4th minus 3/4 x cubed plus 10 and x is equal to -4.
Okay, and real quick, is this the synthetic substitution or direct substitution? Okay, so for direct substitution, what does that mean? We directly replace what? X with a -4. So I just replace every x with my number, and I use my order of operations to go from there. So my x number is -4. So I just substitute it in, and make sure you're using parentheses, especially if you're typing this into your calculator. Okay? No parentheses pretty much guarantees you will get it wrong. And if you do type this into a calculator, you will need to put the fractions in their own set of parentheses like that. Everybody okay? Yes or no? Okay. So, let's evaluate. So we're just going to move one piece at a time, right? Order of operation says I do what first? Parentheses, right? Is there anything to do inside parentheses? No. So what's after parentheses? Exponents. So I have to deal with these powers. So what is -4 to the 4th? 216, right? 256, really? Wow, okay. I messed that one up. Sorry. Oh, 16 squared is, oh yeah, duh. Sorry. My brain space, man. I took 6 cubed instead of 16 squared. I don't know what's going on. So everybody okay with how we got 256? Yes, no, maybe. So when you type this in, you need to make sure that you put the -4 in parentheses, or else your calculator will spit out a -256. You don't get the entire problem wrong. Okay? That's why we have to use parentheses when we're typing this in. What is -4 cubed? 64 plus 10. So now I get to multiply, still using my order of operations. So it's half of 256, 128, right? Okay, what is 3/4 of -64? So negative times a negative is positive. 64 divided by 4, 16 times 3, 18, 48. Did you put in a negative here? Yep. Yeah, so if you can't tell, when you're typing this in, signs are huge, okay? That's why most of you, given the calculator types that the majority of you have, well, let me finish it up and then I'll get to that. But remind me to talk about calculators. So now we just finish off. So -4 plus 128 is 124. Plus 10 is 134. Plus 48, let me see, 134, 142, 182. And that is your final answer. So this is what I was going to say. As far as calculators go, you can use your calculator and just type in this entire statement as long as you set up everything with parentheses. But there is a minimum level of expectation. And this is what I need to see. You have to show me your substitution step. I want to make sure that you're putting everything in with parentheses properly. Okay? One of the sections later on in this chapter has us graphing polynomials, where you're going to be graphing cubics, quartics, and quintics. So what that hinges on is your ability to type values into a polynomial. Whether it's using direct substitution or synthetic, you have to be able to do it quickly and accurately. Everybody good? So I need to see the substitution step, and then you can go to the answer. Just be right when you type it in. Okay, if you're not getting answers that match in the back of the book, come up and see me, because 90% of the time, it's a parenthesis issue. The other 10% of the time, it's a sign issue. Okay, and we'll get you straightened out and get you up and running again. Everybody good with that? Yes, no, maybe so. All right. Any questions on 13? You just put it in parentheses. Division. Yeah, use the divide button. Don't use, and real quick, do not use the ABC button, the fraction button on your calculator when you're evaluating. Use the divide button. If you want 3/4, go open parenthesis, 3 divide 4, close parenthesis. Okay? The fraction button creates some weird things from time to time. All right? It messes with your computer's programming a little bit, and its order of operations get a bit wonky. So make sure that you're using the divide button for fractions. Everybody okay with that? Yes, no, maybe? Okay. Hey, thank you. So after 13 is 34. What does number 34 say? And what's the equation? Okay. Now, we actually did talk about this a little bit. So what we're trying to figure out is, I know the book says f of x instead of y. They're interchangeable. Okay. What this statement is saying is they want you to figure out what's going on with our y as x approaches negative infinity. So for our xy grid, right, which way is negative infinity for the x? Is that all the way to the left or all the way to the right? To the left. So what we're saying is, as x gets super duper small and gets way out here, I'm talking like out here, okay, what's going on with y? What is it approaching? Is it pointing up toward positive infinity, or is it pointing down toward negative infinity? And that's what we mean by end behavior. We're talking at extremes, okay? What's going on when we're at negative 10,000 on the x and positive 182,000? Which way is the graph pointing? So this is where we start when it comes to polynomials, is just identifying end behavior. So to do this, we have to find out a few characteristics. So the first thing that I need to know is the degree of the polynomial. So what is my degree up here? 3. Okay, if the degree is 3, is this an odd or an even function? It's an odd function, so is this an S or a W type? S. So that means that the ends are pointing in opposite directions, which means one will point up and one will point down. We're either up in the first, down in the third, or up in the second, down in the fourth. We need to figure out which. The number that determines which way we're pointing is the A. So what is my lead coefficient up here? Is it positive or negative? Positive. So this is the information I'm looking for. Okay? So if you took notes on this, good. If you didn't write it down now. I gave you this chart. This is what we are using. Okay? So do we have an odd function or an even function? An odd. Was the A positive or negative? Positive. So what is our graph doing? Up in the first, down in the third, which means, hey, come on, thank you. If I were to graph this, I have no idea what's going on in here. All I know is that my graph will point up in the first and point down in the third. Okay? So, now to fill in the actual answers. Y approaches blank as x approaches negative infinity. Again, which way is negative infinity for x? To the left or to the right? To the left. So as I move to the left on my x, what's happening with our y? Is it pointing up or pointing down? Down. So as I move this way, my graph is pointing down. If we point to the left forever, we point down for how long? Forever. So how do we say forever down in math? Negative infinity. So y is approaching negative infinity as x is approaching negative infinity. Everybody okay with that? Yes, no, maybe? It's coming back. So y approaches blank as x approaches infinity. For x, which way is positive infinity? To the left or to the right? To the right. So I go to the right forever. Which way am I pointing? Up or down? Up. How do I say up forever in math? Positive infinity, and you're done. That's all they want you to do. Identify the end behavior. Okay? And every time you do this, the only part that you have to fill in are the dashes on y. Okay? And I know this seems like not that useful right now. It's going to be monstrous the further we go. Okay? You guys remember domain and range from last year? And a little bit this year? Well, I told you in chapter 2 that every chapter we have at least one section of graphing, right? From here on out, every one of those chapters where we graph, you have to be able to identify domain and range. That's what we're starting with here, Okay? So domain and range become very important because they allow you to quickly analyze a graph and figure out what solutions are possible. Okay? And that's what we're going to be looking at. It helps you determine the shape of the graph before you even start a problem. Okay? Everybody all right with that? Yes, no, maybe so? So it's going to be something that does not go away. From here on out, we're going to be dealing with end behavior and analyzing domain and range. So if you don't learn it now, it's going to be coming back. So we got to get it figured out at one of those points, okay? Yes, sir. Yeah, okay. So they give you this part, right? As x approaches negative infinity. So from x's point of view, which way is negative infinity? To the left or to the right? To the left. So all I'm trying to figure out is what's going on with y. If I run to the left, is my y getting bigger or smaller? So as I move to the left, is my graph pointing up or down? Down. So how do I say down forever in mathematics? Ta-da. That's all we're doing. Okay? Everybody good? Well, no, it's one of those things where your brain tends to overthink it. Like, no, it can't be that easy. Yeah, it actually is that easy. You want to know what's hard about this? Having this memorized. Knowing that if it's an odd function with a negative a, you're in 2 and 4. Knowing that if it's an odd function with a positive a, you're in 1 and 3. A is the lead coefficient. Okay, so you look for your biggest power. That determines the degree and whether the shape is an S or a W. And then the A determines whether it's 1 and 3 or 2 and 4 or both up and both down. Okay? So being able to identify degree and lead coefficient is what we need to do. And again, the setting that I gave you yesterday is where you're really going to be using this. On the ACT, they're not going to ask you to graph this equation. They're going to say, which of the following pictures, which of the following graphs is the appropriate graph for this equation? And you have to pick from 4 different pictures which one's right. Okay? So based off of this, you should be able to look at it and go, okay, it's an odd, so it needs to be an S. N's pointing in opposite directions. A is a positive, so that means that I'm up in the first, down in the third. Any picture that does not go up in the first, down in the third, throw out. It's impossible. Everybody okay with that? Yes or no? The second and fourth quadrant is when A is a negative. So that would be up here, down here. So the way that I remember it is an odd is supposed to be in the odds. So an odd positive is in the odd quadrants. An odd with a negative A flips. Because it's the opposite of negative, or opposite of odd. Does that make sense? Oh, 1, 2, 3, 4. So top right is 1, and then you go counterclockwise. Okay? So being able to actually analyze it quickly can really help you out when it comes to the ACT, because then even if you have to guess, if you can throw out 1, you went from a 25% guess to a 33% guess. If you can throw out 2, you went from a 25% guess to a 50% guess. Everybody all right with that? Yes, no, maybe? So that's why this language is so important, is it gives you the background knowledge to be able to speed up your calculation. Because you can perform analysis and determination while you're working through stuff. Everybody good with that? Yeah? No? Maybe? I don't know. I don't care. So good? All right. So are there any other questions that you need to double check, want to make sure of, or are we doing all right?